The integral of cosine to the fifth x times sine x dx, we can let cosine of x be our u substitution. The derivative of cosine is negative sine x dx. In order to account for the rest of the integral, after we make our substitution, we're going to have u to the fifth here. Sine x dx, once you isolate that in your derivative line, that's negative du. So we have negative du. And that takes us to integrating. Our antiderivative of u to the fifth is u to the sixth over 6, or 1/6 u to the sixth, keeping our minus sign and adding our constant of integration. Replacing u with cosine x gives us a final integral of negative 1/6 cosine 6 power x plus c. In our next example, we have the integral of sine cubed of 2 theta times the square root of cosine 2 theta. First, let's rewrite this radical term with a power of 1/2. Sine cubed can be broken up into sine squared, and we'll leave a sine to the first as a leftover. Now, one of the purposes of that is we can use Pythagorean identity and change sine squared 2 theta to 1 minus cosine squared 2 theta. Distributing cosine to the half, we have cosine to the 1/2 of 2 theta minus cosine of 5/2 2 theta. Remember, when you're multiplying, you add the exponents for like terms. So we have cosine 1/2 2 theta plus minus cosine 5/2 2 theta. The purpose for leaving an extra sine 2 theta on the end is now we can use cosine of 2 theta as our substitute. Its derivative, applying chain rule, is negative sine 2 theta times 2. Back in our original problem, that's going to make us have the integral of u to the half minus u to the 5/2. This sine 2 theta d theta, once you isolate that in your derivative line, you can replace that with negative 1/2 du. Negative 1/2 is a scalar, pull it out front. Du we leave back here. Now we can take our antiderivative of those u terms, and we have add 1, so that's u to the 3/2. Dividing by 3/2 is the same as multiplying by 2/3. Minus, add 1, we have u to the 7/2. Dividing by 7/2 is the same as multiplying by 2/7. Changing u back to terms of theta, we're going to have cosine 2 theta go in for both of these u's. Distributing negative half, that's negative 1/3 cosine 2 theta to the 3/2 plus 1/7 cosine 2 theta to the 7/2 plus our constant of integration. A definite integral using Wallace's formula, we have the integral from 0 to pi over 2. Now, there is some strict stipulations for Wallace's formula. The definite integral does need to run from 0 to pi over 2. This can be found in your e-text on your WebAssign account. If the power of sine or cosine is odd, then you start with 2/3 and you increase your numbers and build fractions until you get to a fraction where the exponent from the original problem is your denominator. Now, if your power is only 3, you don't have to go far. It's only going to go to 2/3 because your bottom number is the power from the beginning problem. So this actually has a value of 2/3. Now, had this been cosine to the 7th, you would build it all the way to 6/7 and you would multiply these three fractions. 2/3 times 4/5 times 6/7. Again, whatever power you have, that's where you stop. Since we only have a power of 3, we stop at that first fraction because its denominator matches that power. Now those are for odds. Below we have an example where the power is even. Now if the power is even, you start with 1/2 instead of 2/3, but you still build your fractions the same way with consecutive numbers. 1/2, 3/4, 5/6. You go all the way until your denominator matches your power from the original problem. And then once you calculate that value, multiply by pi over 2. So for this one, since it's a power of 4, we go 1, 2, 3, 4. So you stop after two fractions. 1/2 times 3/4, that's 3/8. Don't forget to multiply by pi over 2. 3/8 times pi over 2 is 3 pi over 16.